Okay, so again, I would like to thank you for joining us, Oxana and Carolyn. I know both of you are busy, and I would like to invite Pieter as the moderator of this panel, and let's start.
Okay, hello. It's really improvising. I'm looking at the back of half of the panel, which is a bit odd. But yeah, we're going to improvise. Oh, now my panel is. Oh, okay, great, wonderful. Okay, well, welcome everybody in the panel and online and in the room. So we got an hour or so to discuss responsible research, innovation, ethics for quantum technology, or in quantum technology is the formulation. I propose that we start with a little round of introductions, but also saying something what your experience is with RRI, and what's the main challenge you see, or your main observation, if you have a positive spin to it, about RRI in ethics. Does it exist? Is it possible? What do you encounter? I propose that we give our online participants the floor, the electronic floor, as first, in order to give them more access to the flow of communication. Caroline, would you like to start? Briefly saying who you are, and then
yeah. Thank you very much, Pieter. Very nice to be here. Thank you very much for inviting me. I kind of wish I could see the room, but you know, you'll just have to look at me. So I am Carolyn Tenhalter. I work in the Responsible Technology Institute here at Oxford, and I look at responsible innovation in a variety of novel technologies, one of which is quantum computing. I also look at autonomous vehicles and AI and mental health of adolescents online, so a variety of domains. And I'm involved with the Quantum Computing Hub here, which is part of Oxford's Quantum Institute, which is relatively new. And my original doctorate was funded by the first Quantum Computing Hub, and I now have a project starting in January with the latest iteration of the Quantum Computing Hub doing responsible innovation. And where to start with the challenges? I think I'd like to pick up on something that Rob said in his talk about the need for kind of a systems thinking approach when it comes to the creation of a quantum computer. You know, you need to think about the trade-offs between various parts of hardware and so on. I see the same kind of challenge in the responsibility space, because quantum computing obviously doesn't happen in a kind of social vacuum. It's surrounded by industry decisions, people making advances in academia. There's an awful lot of policy backup. And so what's called the triple helix model of academia, policy, and industry, very, very tightly wound in quantum computing. Academics are running startups, businesses are funding research. The whole thing takes place against significant sort of policy interest from governments. There's a lot of funding. There's also an increase in protectionism that we've seen as people kind of start thinking, oh, well, this is a matter of sovereign capability. And so all these factors kind of tie into each other. And it's a very kind of big space to be trying to do responsible innovation in. This isn't like a little research project where you have a beginning, a middle, and an end. This is a huge deal across multiple continents and types of technology, all the way up through the quantum stack. Rob was talking about you start with the hardware, but then by the time you get up through operating systems and algorithms and applications and so on, there's a lot going on. And so one of the biggest challenges I see is actually deciding where you are going to focus your efforts, because doing RI in quantum computing is huge. It's the wrong unit of analysis. you have to look at, you've got to be able to break it down somehow and figure out where effort is needed, but also where you can be most effective. And some of the biggest challenges I see right now are coming from the hype side of things. There's a very good recent video by Sabine Hossenfelder. And I think there is this responsibility on scientists who also understand the kind of responsibility aspects to really reach out to media, to work with media and journalists and publics to try and bring some of these expectations back into the field of reality. I mean, there are so many headlines about quantum computers going to break the internet, going to break security. We are years and years and years away from a cryptographically useful quantum computer, but that doesn't appear in any of the stories. And what we don't want is for all these massive expectations to result in then, a crash and a quantum winter and so on. Because then, it's not just that the quantum computing work doesn't get done, the societal and responsible work doesn't get done either. So I'll stop there and hand over to Oxana.
Okay, yes. Go ahead, unmute, please.
Okay, thanks, Caroline and Pieter for the panel, and Jackie for inviting and organizing. And nice to be here virtually. I am now in Italy, in Trieste, and this is the city which is close to the border with Slovenia and Austria, which is very much not Italy to expect from foreigners. And I work at the National Research Council of Italy, which is a big research institution with institutes all over Italy, more than 500 institutes. And the institute I work in is called National Institute of Optics, and it has five seats around Italy. Now I am working full-time practically for the coordination and support action of the Quantum Flagship, the European initiative that has been already mentioned by Zeki. And it has been since the past 2 years that I'm dedicating all my time to this. Before I worked as a theoretical physicist, so I know a little bit the rim of a researcher. Pieter was mentioning a lot today. And then I had experience in education research, in physics education research, in particular on how to teach quantum physics. And then I got into the coordination and support, and specifically for the purpose of education and community building for doing education in quantum technology and for quantum technology. And this was my life in the past 2 years, and now the gears are shifting. And since I know there will be a panel later on education and I need to change my hat, now I got much more responsibilities and duties related to equity, diversity, and inclusion topics, which I think are crossing also a lot with ethics. So, and I will be wearing this hat in this panel. So the challenge that I wanted to bring here today, I'm afraid it's very big, but I don't know where to bring it if not here. And it's actually, I hope for your feedback and supporting if you feel this or not, but from my observation, the biggest challenge is time, actually. It's also reflected in the Caroline's talk that one needs to focus. But when we say that it's about this innovator or this researcher to embark an ethic points or diversity points or other points that obviously are very important for technological development, where does this researcher get the extra time for it? whether it's him or her, or it's a guide for him, somebody that is working on this topic extra in this institute, but he needs to talk to this person. So it's this issue of having room practically for integrating points. And I think here we are in a big trouble, because we are already facing a work-life balance issue. And this is my hat from the diversity challenges. This is the main reason practically why the field is less attractive for women, for example. And we are going to add more tasks to the agenda of people developing these technologies. But how to do it in such a way they can embark them?
Yeah.
Okay. So this is the challenge I'd like to bring here.
Okay, we're going to solve it too. Because we're physicists, so we're going to solve problems. Yeah, easy. So early lunch. Thanks, Oxana. Okay, let's move to the room. Yeah, talk, please.
So, spoiler alert. My challenges resonate with Carolyn's and Oxana's. One about unit of analysis and one about incentives for incorporating responsible innovation into different practices. So I'm Doug Robinson. I work at the CNRS in France. It's a bit like the CNR in the way it's set up in France. There are about 30,000 staff members of CNRS. It's a very large research institution in France. I'm also associate researcher of the Institute for Innovation and Public Purpose at University College London with Mariana Mazzucato, who works on mission-oriented research. So I'm located there. My background originally, as many people seem to be, is a physicist. And then I retrained in science technology studies in the nanotechnology wave of the early 2000s. And so many of my comments come from experience embedding constructive technology assessment and responsibility in the nano. Now, the challenge that I want to bring up, and I'll be as brief as possible, is quite similar to Carolyn's about unit of analysis. How do we break it down and where do we locate our activities? We've heard from some of the presentations in the morning about hype and hope around quantum, about the different kind of application areas there will be. Are we going to be discussing and locating reflexive analysis on visions of what quantum should be? Are we going to be locating and breaking down different elements of the system diagram that Robert showed this morning, different people coming together to build quantum? Are we going to be enabling them in different ways to be bringing responsibility, norms and values into their work? And that is where, again, spoiler alert, Oxana's point about incentives. When there's high pressure to deliver on all sorts of fronts, there are motivations for researchers and people working in innovation organizations, be it in private sector or public-private organizations. There may be willingness to incorporate some of these things, but the actual institutional structures have to be changed to incentivize those to bring in these aspects. Now, in the nanotechnology days, we experimented in the Netherlands of including in natural science training some social technical or STS components or philosophy component. We did that in Université Twente. It's very difficult for them to justify, even if they had official time on this. So the incentive structures, the institutional setup, I think is very important and a key challenge if we're going to arm the quantum technology workforce to incorporate or even begin to be sensitized by some of these other issues. I'll leave it there.
Yeah, okay, thank you. Let's go to our final panelist.
Yeah, so I've just talked for about half an hour, so I think I've said most of the things I wanted to say. So I should just maybe say a little bit more about myself because I skipped over it a bit. So I, in some sense, am the archetypal example of a pure quantum scientist who never thought about applications until a couple of years ago, who had worked on trying to understand the beauty of quantum physics for many years, and typically writing a few sentences in grant proposals about one day it might be useful for something, with some hint at what it might be useful for. And now we're suddenly rushing headlong into startups and companies making huge claims, and politicians worrying about things that are often very far from the current situation, I think. And us as scientists worrying about, are we too pessimistic or too optimistic about what could happen? You know, there's these famous citations that when a scientist says something is impossible, you know, when a famous scientist says something, I've forgotten the exact citation, but when a famous scientist says something is impossible, it's usually done within 20 years. And when a famous scientist says it's possible, it's done even faster. But there are plenty of counterexamples. Nuclear fusion is one that has been, you know, when I was a student, they said it's been 50 years, we've been saying we'll have it in 50 years. Now 25 years have passed, things are advancing, but they're advancing slowly. And who knows what is the good point of view. I think the hype is very frustrating because it forces us as scientists to be to oscillate between being pessimistic and optimistic in an uncomfortable way. I wanted to mention, okay, maybe I can mention one thing about money. I am very uncomfortable talking about the various figures that were shown right at the beginning in terms of billions. And so I always try and bring these numbers back to other scientific projects. So I just looked up a second ago on the internet for the first link I found on Google for the cost of discovering the Higgs boson at CERN was 5 billion, in what I don't know. And they point out this is the same value as the New England Patriots. So when we talk about 5 billion or 20 billion or whatever the figure is, on one hand, it's a huge amount of money. On the other hand, it's it is perhaps a reasonable amount of money to not worry about applications and just to say we're trying to understand nature. Unfortunately, that's not how we have been given the money. We've been given the money for our applications, which is, it's not like the Higgs boson where people just said, okay, we want to understand the nature of the physical reality. And this is another challenge for us. So yeah, maybe I stop there. Yeah.
Okay, thank you. Yeah, so let me play a little bit devil's advocate. It seems that, okay, nice challenges. So we need to focus, so we don't have it yet. Okay, too bad. We can do that for lunch, I would say. A practical problem, another practical problem is okay, how do we get the researchers engaged to spend time on it? How do researchers working on quantum technology themselves? Seems also a practical problem. It seems banging the table a little bit at the meeting, say, okay, if you want to have a successful technology development trajectory, you simply have to. Are there also principal problems of responsible research innovation on quantum technologies? Is it different if you do it for quantum technology as compared to other technologies? And this is a question I would like to ask to Caroline, because you described that you do responsible research innovation on different technologies. What kind of contrasts do you sense? Should we adjust our way of doing responsible research and innovation for quantum technologies?
I think there are things about the quantum space that make it unique technologically. But in terms of how you do responsible innovation in the space, I think it's very much the same kind of questions that you need to be asking as in other technologies. So Rob was talking earlier about the sustainability and the energy usage of quantum systems. We need to be looking at that across the ICT, the whole ICT space. Yeah. How much energy does a machine learning model use? Answer: it's horrific. And when it comes to algorithms, you know, we need to be asking the same kind of questions in terms of responsible algorithms as we do with, you know, general or, you know, AI normal machine learning models. So, you know, when you kind of break it down into its pieces, I think the kind of approach still needs to be the same. I'd also like to come back on both kind of Oxana's and Doug's points. Doug's experience with embedding RI into Nano, and Oxana talking about how we're adding to people's tasks by asking them to do responsible innovation. I think some of that actually comes down to how we train physicists. We don't train them in these responsible and ethical approaches. And so it tends to be regarded as an add-on, whereas it should be kind of an automatic approach. These should be mindsets that are built in from day one. And it's a little bit frustrating to hear about and to read elsewhere about the difficulty of embedding responsible innovation into nano research. And why did nothing change? Why do we still don't educate computer scientists and chemists and physicists and biologists in kind of responsible and ethical approaches such that they are automatic? You know, this is just the way you do your work, the way you operate in your daily life. It's not an add-on, it's not a tick box. It's not something that kind of you have to make time for in your research. It is just the way you do your research. And so I think people like Oxana looking into how we teach physics, the pedagogy of these subjects, is critical to how we can embed more responsibility in the future.
Okay. Let's go back to the physicist in a moment. I want to first also hear other voices about whether we should adjust the research, responsible research innovation tool for quantum technologies. So if I understand you, Caroline, you say, no, we can just do it also for quantum. There's nothing really different there. Do you agree, Doc?
I mean, again, I also look at different technologies, but I'm going to draw on the nanotech case because I did my PhD in it. So I have a lot of data a long time ago, but still. One of the differences between quantum and nano was the nestedness of quantum, and I think Caroline mentioned this in terms of the different types of elements that come together for quantum computation or any kind of quantum technology. In nanotechnology, it tend to be a fundamental building block, like a little bit of a new material or a nano channel or something like this, that would then enter a system that exists rather than reconfiguring the whole system. And so when we had, not purely the case, but in the areas where I was working, yes. And so the way of thinking about the future wasn't so difficult for many people, many nano researchers to think. They would think, okay, it's about applications. I can see the direct application, even if it's different sectors that my nanotechnology may go in, I can start contemplating that world quite easily. In quantum, I think it's a bit more tricky because when you start thinking, well, okay, why am I responsible for being responsible here? I work on a very small component, maybe on the cryogenics in your system, yeah? Why am I having this discussion? Why do I need to do this? It's a different world than in the nano case and in some other cases. And I agree with Caroline and I agree with Oxana. It's about education. That should be across the board to build to sensitize those enough that they can start positioning themselves and say, well, okay, these are the kind of questions that I should be grappling, and it has value. It has value because I want to do my bit for science. I want to be a responsible researcher, but also start thinking about transferring the knowledge that they're producing to the greater development of quantum computer or something like this.
Yeah. But, do we agree that in principle we can have this societal dialogue about quantum technology, but these physicists block us. But if they would not have blocked us, everything would be fine. So originally, this argument, no one understands quantum technologies or quantum mechanics. So this is there kind of shared feeling that this is not a problem? I can't see Seki. What's happening in the chat?
I don't see anyone.
Okay, nothing in the chat.
Oh, we have to open it up. We can't see all the questions.
Right.
From Mira. Yes, that would be good.
Okay. It's from Mira. He said, the question for all panelists: how effective do you think RRIs can be when some of the key stakeholders see normative questions as the thought on nuisance paradigm they have to write about in funding implications? Or something so soft that it doesn't have any priority regarding the development of the technology.
Okay. Well, that seems like an excellent bridge to talk about physicists and other actors in the
Repeat it,
field.
please, Peter. I couldn't hear it well.
The question.
You might be able to read it.
Read it, Oxana. It's in the chat.
Ah, okay.
Maybe I can say one thing that occurs to me as a physicist who understands quantum quite well. I don't understand anything that happens in my telephone. My smartphone has so many things going on it. I don't know what it's capable of doing, what it's not capable of doing. That doesn't stop society that shouldn't stop society having an opinion, and particularly deciders having an opinion about telephone technology, 5G and so on. Quantum, the fact that maybe it seems more esoteric or mysterious, when you're inside of it, of course it doesn't. So I understand that from the outside it looks maybe there's an extra barrier there, but I don't think there really is. I think, you know, our society is used to a democratic society is used to non-experts making decisions based on their best understanding of what the experts on that thing tell them.
Yeah.
So in that sense, I think it should be like any other technology, but I understand there's another maybe psychological barrier of the fact that quantum is sold as very mysterious, and indeed it has some very bizarre things in it.
Let's go to just a small question to Mira. Is it your experience that people at IBM don't care about normative questions?
So maybe I'll just quickly unmute myself to answer that. Yeah, so I think it's very much sort of an afterthought or something soft. It's been, I mean, you notice that I can now start working on this, but you know, it's been a sort of a road to get there. It's taken quite some convincing, and it's also taking quite some sort of convincing that this is taking a serious research. So it's, I mean, it might also be something, you know, we're talking about the physicists versus the philosophers, so that the philosophers are being taken seriously within a tech company. But it's also something that that speaks to Carolyn's point on the education and also the upbringing, so to say, of physicists, where this has always been part of, either they had to take some credit at their university degree, but they did it because they had to do it, not because they actually cared, or they have to write a paragraph in some funding applications about, I think someone else was saying earlier, the relevance to society or like the ethics of it, but without really understanding the implications of it. While all of them are being funded on tax money, so they very much are working based on societal money, but are not sort of, there's almost this cognitive dissonance to making the link back. Then working on public money means you're doing something for society, hence you should be thinking about the implications, and that hence you should be thinking about the implications. It's almost like a no-go area, or people who go that area, the few people, the colleagues who are doing that, it's regarded as soft, and you know, you do that because you have additional time and so on. So yeah.
Thank you. Let's turn to Oxana. So you got the question by Caroline about physicists working there. What's your experience with getting physicists on board in societal questions, normative questions?
Well, now I have a lot of experience in going around and talking to students about quantum technology and motivating them to engage in quantum career in the future. And I see there is a lot of resonance with them when I say that it's, at least in Europe, has been bottom-up initiative, and there was Quantum Manifesto, and the community of researchers have thought about it upfront, dreaming for good for society. At least this is how I present it to the students and how I like to believe this was actually, despite that now it has becoming much more integrated into a race and competition and into a lot of pressure for survival for some. This is a big resonance with students, and specifically with a diverse audience of students. And I think this is what attracts young people into the area specifically, that they will be able to dedicate their time and effort not only to fundamental discoveries, but also to societal challenges. They are bombarded through old media every day. So I found, as a response of students, the young audience, attractiveness from this perspective of quantum technology. So from this point of view, I would like to say that technologically wise, I think ethics shouldn't be that different between different technologies. The questions are the same, as Caroline said. The difference is in the context of which we are now developing quantum. We have lots of investment into it, so it's a very special moment in time. It's practically a special moment in time. And there is a lot of time ahead of us, so we have time for anticipation. If we talk on a long scale, not on a personal time of every day of a researcher, but on a long scale, we have time for anticipation, and we have time for preparing us. And so we should definitely use it. And maybe in some areas, it has been different. Like now I see, for example, with digital, it's the opposite. It looks more to me that now everything has to be digitalized. Oh, and what about ethics? When the technology is already there in a way, but yeah, so that is my lame view, because I'm not an expert and I don't know much about this topic development, but this is how I see a difference between ethics in quantum and ethics in another technology is the specificity of the moment in time on which we started to ask questions. And I think it's very positive point that we still have time ahead of us to provide this to the future generation.
So an observation which you make is that the influx of people, so the young people who enter the field actually are more open to normative ethical issues as compared to that physicist which we portray here as kind of the hardworking person who only focus on physicists. I want to check whether that assumption is actually right, whether it's right that we are only dealing with those kind of hardcore physicists. What I saw in my own university was that the first step which had to be made to arrive to a quantum computer was to give the engineers an equal spot on the table, and the ICT people. So it's not anymore a physicist game. And that might give possibilities to indeed introduce more kind of soft skills. Doc, I saw you nodding.
Yes.
What's your perspective?
I'm nodding because I'm married to a physicist.
Yeah, we seem to have this physicist perspective.
No, I was thinking about this. I was talking a little bit earlier about the kind of communication devices between the different research scientists and engineers that are involved in the developing of any type of quantum computing system is one of the things is when you start looking and unpacking the way the communication goes between them and how are they kind of negotiating, opening up the little black boxes that Robert put in that system. Everybody has their special corner, and they themselves have to communicate to others with a different frame. And I think one thing that I find very useful about this idea of framing is really unpacking how the different actors frame their work and their relevance and how they connect up with others. And again, with nanotech, I keep going back to that, it was a nanoscientist thinking about industry in various ways. Whereas in the quantum world, it's physicists working with engineers, working with IT, working with people in a facility on the cryogenics and having to kind of co-develop these things. And so I think there's an opportunity there to start looking at the intercommunication within science and putting a little bit of sensitizing to some of these other ways of thinking about the future and how things are going. I'll stop there because I'll just keep rambling on. But
do you see something like that happening? Diversification.
Yeah, so I guess I have a bunch of comments about ethics. So the first thing is that the physicists who work particularly on quantum science are nearly all of us come from a pure scientific fundamental science background, which means one important thing, which is in our philosophy, let's say, it's a bit like freedom of speech. Everyone believes in freedom of speech. We feel we have complete freedom to explore the laws of nature. And while that's all we're doing, we feel that's the end of the ethical discussion, rightly or wrongly. And so now all of these people are suddenly being dumped into a domain where technology comes into play, where it's clear that there are, I think as citizens, we all understand that there are always ethical issues related to technology. Physicists experience this very strongly with nuclear weapons. So as a community, we're not alien to it. Then there's a trouble that and so this is maybe a question for Oxana, is that typically you learn how to do research from your supervisors, not from lecture courses or anything else. So is there a risk of perpetuating a style of thinking or a style of doing research that maybe was legitimate when it was fundamental science, but those people are now, and myself, we are now shifting maybe into more applied things where maybe our way of evaluating things is wrong.
Okay.
And then how do you stop that being passed just automatically to the next generation without any reflection?
We'll go to Oxana in a minute, but I saw Caroline raise her hand, because also in your paper you wrote, Caroline, that there's a kind of latent wish among the physicists to get heard by the politicians. So meaning that they do have a wish to look at the broader context.
Yeah, I think that's that there's no channel up to policy, and actually it was the policy aspect of Myra's earlier question that I wanted to address, because writing about these approaches in funding applications is great as long as the funder is taking it seriously. And this is something that we've seen to varying degrees with the Engineering and Physical Sciences Research Council in this country that funds a lot of this kind of thing and has embedded RI as part of funding calls. So people making an application for funding are required to put in a responsible innovation section in their funding calls, but it's still not assessed. It's not a red line. It's not the case that if your RI approach is deemed to be unacceptable or insufficient or not properly embedded, then your proposal will fail. But it is there. And if we can lean on that, if we can push policy in that direction to make them take it seriously, then it has to be taken seriously at the research level.
Pieter, can I just add
How
to
you
that?
do it in companies, that's a whole different thing. But there are people out there like Ilyas Khan who understand the importance of ethical approaches.
Okay.
Yeah, I just wanted to add to Carolyn's, because I've been an evaluator for the Norwegian Research Council as an RRI expert, and that they started putting in RRI experts in the evaluation of ICT and security. I'm allowed to say that, I'm not allowed to talk about the proposals, but I can talk about that. And the point is, Carolyn, you know, they're actually putting it as a red line in some of their evaluations, so ICT and so there's illustrations of what you want to do in the UK, in Norway, and so I've got a feeling that one of the issues that goes is, we don't have to say it, but some comparisons of the different countries and how they approach these things, especially at the research level in terms of funding, I think is really important for the economy.
Yeah. Oxana.
Sorry, may I just quickly ask to the person who was commenting now, does it also imply funding line? So in the sense that the research project that is the application which includes the significant RRI and ethic dimension, will it also have a, let's say, dedicated fund for a maybe qualified person to be on board on this team?
Yes, so so I'll just take a minute and explain this. Every single application for that call was different, and so it was up to the RRI evaluator, that's me and probably some others in other calls, who would make a judgment with the rest of the panel who was assessing whether RRI was very crucial or a very useful thing, whether it was something that would really facilitate in the long run. And so there's some value judgments being made by the individual evaluator. And so that was quite interesting. And to answer your question shortly, Oxana, where it was seen that RRI was crucial, really crucial for this technology area, yes, they had to demonstrate that they would invest in an RRI budget line in their project to be funded. But then again, some projects, it wasn't so relevant, it was on a very fundamental component, and so the RRI element would be rather limited, but still had to be demonstrated.
Okay, which country we're talking about? Just
Norway.
We know, okay.
Norway. Hey, we got another 5 minutes. I would propose, since we solved already 2 questions. One is there a difference between RNI in quantum or elsewhere? The answer is no. So that's we can just for the minutes put that down. The physicists have to be taught a lesson, and it's a red line through financing. Then they'll turn over too. So that's solved too. So the focus. So that was a topic which was mentioned by Caroline and Oxana, is we need to focus. It's so big a field. I interpreted for doing effective RRI, we have to choose. Okay, and this is a question for the audience. Which focus would you prefer? And so we have a problem, just start brainstorming. What kind of focus shall we choose? An application or to get going, to set our flag in the field? Any idea?
There's a participant with their hand up on Zoom.
Can you have a chat? Look at that. I can't see.
Joachim with your hand up.
Yeah, that's me. I can also show my here.
So what's the focus, Joachim?
Yeah, so I actually put up my hand before because I had a comment to the discussion before. So maybe I can sort of like just mention that quickly, and then I can perhaps say something that would go towards the focus.
No, only if you have a focus, you're allowed to hack the system, which is fine to hack the system. Just give you a question, but then we need to focus.
Yeah, so I think 2 questions would be, one is how much do we even know about how physicists and other technicians working within quantum, how much do we know about the kind of ethics that they actually already you can say think about or do in their work? So that's more like an open question of maybe not just assuming that they do not do ethics, but rather figuring out like how is it that they see their own responsibility and role in terms of making and disseminating quantum technology in the future. So that's one, I think it could be a focus, but that's also a question. The other question is more towards what about the limitations of responsible research and innovation? This panel is about ethics. And I'm not sure that all ethicists would agree that RRI would be the answer to ethics in general. I would assume not so. But I think RRI has like a lot of interesting insights and processes. Yeah. But I think that it might be also interesting to look at some of the assumptions that goes into RRI, and then also open up the question to
Joachim, in light of time, since we're just finishing the panel, I would refer those questions to the chat. They're good questions, but so please respond to Joachim on that on these topics. The focus. So what for finishing this panel? How can we help Caroline, Oxana?
Limitations of responsible research and innovation.
The limitations. Okay. Yeah. Thanks. Any other? I was more thinking about a use case. What is a use case to get going? And so the energy usage definitely is clear case, which I would say should also appeal to industry and engineers.
Yeah, I think it's something that in some sense scientists and engineers can talk amongst themselves about and come up with numbers which then can go to a broader society. And that's something sufficiently close to physics that I think we probably don't need to develop a new methodology. I may be wrong. On many of the other questions, I don't think we have any idea of, I don't think we think about them as physicists. So it's just, we think about maybe as citizens, but not as scientists at all.
Yeah.
So, which is maybe dangerous, or certainly dangerous.
Because that case of energy has an efficiency at the norm, and then
it's all the things scientists like. So
yeah,
it's an
efficiency and the climate. So that's pretty stable grounds. Caroline, you wrote in the paper that you drove with a bus through the UK, chatting with a kind of roadshow to explain quantum technologies. What was a topic which the public would like to put on the table?
It's interesting talking to or engaging people with people about quantum, because the kind of the broad brush answer you always get to is we don't really care how it works as long as you do it carefully and sensibly and with due regard to public money and there's good governance. And so that's why I'm interested in the governance side and in making sure that in 10 years time we're not looking back on horrible quantum computing scandals of some kind because somebody did something they shouldn't have done, and there was nobody there was no oversight. And I think Oxana's point earlier is a great one about we're in this early. This is a good thing. We're talking about these questions at a good early stage.
Caroline, if you may choose, you dumped the question to the audience. Okay, yeah, they don't. If you may choose, so we just have the freedom. Which application would you choose to get the governance good? Where would you start?
For a focus for responsible innovation, I think it has to be at the high level, at the policy level. Governments need to stop thinking about this as a matter of national sovereignty and this is a technology we need to guard and protect and stop everybody else getting our quantum stuff. Because when the field is constrained, when people can't collaborate anymore, it becomes very difficult to have the conversations you need to have. We're at the stage of responsible innovation where we need to be opening up. We need to be talking to stakeholders. We need to be collectively anticipating some of the questions that are going to come up. Joachim's point is a good one, but it's not all about use cases. RI is about stakeholders and engaging and anticipating, and you do that collectively, collaboratively, and I think we're in a good place, but we need to be involving a lot more voices in the conversation. We hear a lot from physicists, we need to be talking to policymakers, we need to be talking to industry and to the public, but you know,
so the sovereignty is actually a nice hook to start working on and draw in parties. Yeah. Okay, great. Doc, you were nodding at some point.
Yeah, because I mentioned in the break that I moved to the OECD next year. So I'm seconded to the OECD on their project on anticipatory governance of new technologies. So I was nodding what Carolyn's saying, because it's the sort of thing I'm hearing before I start my job is, well, okay, so we see this kind of discourse on securitization, technology, sovereignty around quantum, but there is a willingness at the OECD level, the members of the OECD, to look at inclusion and anticipation, and how do you do that around new and emerging technologies, and what sort of entrance points could an organization like the OECD think about facilitating?
Yeah.
And so in terms of use cases, there are two ways of thinking. One is about application area and a vision of that, and then saying, well, okay, where does quantum fit? And globally and nationally. And the other one is at the convergence of quantum with other technologies, and see how, if you said choose a couple of cases, I would say the convergence of quantum and its the power of quantum with other technologies, for example, biotechnology, something like this, or synthetic biology, and how it combines.
Okay, excellent. Robert, yeah, energy you already had. Is there a second one which you?
No.
No.
No, I mean, yeah.
That's good for focus. You need a clear answer. It's just energy.
But I think it's, I don't think there is another. I mean, for me, I think with quantum technology, we are really almost not in the. Even adding the word technology it's almost too early. So in that sense, we're in the ideal place. And I don't think any technology was developed with thinking about ethical issues or responsible innovation so early, but I'm not an expert, so we happen to be corrected.
Yeah.
So for me, it's maybe, if we can fix a focus over the next 3 or 4 years, we will still be in advance on where the technology is.
Yeah.
I hope.
Do you think the vision of quantum technology is out of the hands of physicists now, and that you're somehow trapped by this hype and the way it's been perceived, and or the vision from other sources, industry and their hype, and on a political level? As a physicist, do you feel like you've lost control of what quantum could be?
Yes and no, in the sense we've completely lost control of the communication aspect. But at the end of the day, if you want to build a machine that works, that does a technology that does something, somehow it's still the physicists and the engineers who will do the best they can to build whatever it is. And the laws of physics may stop us building what we want to build. So
I have to thank you for flagging me that we still have 1 minute. Oxana, if you just a couple of keywords, if you are to choose the focus of an RRI effort for the next 2 years, which would you choose?
For the next 2 years, I would add to the energy maybe the primary resources, so materials that like we have to mine and we have to get, and we have to, they are produced probably somewhere in Bangladesh by 12-year-old that is dead after these 2 years.
Yeah.
So I would add this to the plate.
Okay. Wonderful. Is there still something from the chat? As Professor's chair.
Some comments. There's a comment from your team who may wish to say it on the microphone.
In terms of time,
You should go to lunch.
we have to go to lunch, Joachim. So sorry about that. Okay, then in principle, we have also solved that last problem too. We're real physicists, so we have focus, energy, materials, convergence. Okay, there's not much weight to that one. As sovereignty. That seems like an excellent Yeah, yeah, of course. That was so sorry for not being able to address all questions. But in light of the time, we have to go to lunch. Many thanks to the panelists. Okay, fair enough. Thanks a lot. I'll hand over back to Seki for saying something about the lunch. But thanks to the panelists.